Hi guys, got a bit of a mixed bag this time. I have got a little USB hub to have a look at. I've got some new breadboards over here to have a look at, and I've been looking at this little USB host board, which I had a view of connecting to some of my microcontrollers to give them two ports, a device and a host port at the same time. And there is these little boards here that I've been using in several of my projects. And if you've been watching my videos, like for instance, I've used it in the keyboard, I've used it in this little macro keypad that I've made, and we'll get back to that in a minute. And so I've been buying these things on Amazon, and they have been good. These ones here I have been purchasing, and they have all been good. There's been no problems with them whatsoever. However, I found that I already had a bunch of those. I was just digging in my box the other day where I keep all my little boost battery chargers and boost boards and buck regulators, what have you, and I found 4 of them that I bought obviously quite a while ago, some years ago, probably from either from AliExpress or eBay or goodness knows where, Banggood, and they were not good. They had a problem. So we're going to be looking at that and seeing if we can fix them. I have a couple of bad ones, and we're going to be testing those things to see which ones are bad, because I can't remember. They're all mixed up now. Also, I saw this breadboard over here, and one of the problems that we have with breadboards is that two things. But first of all, some of these microcontrollers, like this one here, are so wide that you only get one row of pins. And I thought I saw somewhere that they said that you could use one of these, and I'm wondering if I can remove one of those strips here, because then it would work. But in any case, this breadboard is still, that's too wide. I did make my own. I just glued those on a piece of board, and this is what I've been using. See, I can plug that in like that, and I get 3 rows on one side and 2 rows on the other. So I guess I can continue to do that. But the problem is, these cheap AliExpress, Aligu, or whatever they are branded as, breadboards, I don't like them. I've been having problems with them. They seem to lose, like if you can buy these little kits, you know, with those little jumper wires, but these jumper wires are relatively thin, and when I plug those in here, it just doesn't grab. And half the time when I put in a little project here, I got to wiggle the wires and try to, and sometimes they stop making a contact and so on. So I thought by myself to get a better quality breadboard, and indeed this is a Jamico branded one, and of course, you know, it is 3-4 times as expensive as the cheap Chinese ones, but indeed every little hole here grabs this wire very nicely, and in fact some of them it's a little bit tight even, but that's not bad. You can just plug it in with a pair of pliers, so that is a good thing. However, I'm a little bit intrigued as to how I've seen these things before, and I've always presumed that they had an internal connection. These came loose and you had to mount them yourself, and this is a metal plate, of course, and I always assumed that these connectors, would be connecting to some of these power strips here, and so you wouldn't have to. You could just plug power and ground in there, and you'd be off to go. But that's not the case. There's no connection there. You'd have to somehow do that yourself, and I don't. So I've got to do something about that. I'll have to put some leads on there or something with some little spade lugs, and so that then you'll have to plug them in where you want them, I guess. But in any case, the story is that this breadboard is much better than those cheap Chinese ones. I actually have some little original breadboards here, which are like 40 or 50 years old, and this one here says BIM board made in England. It's a long time ago since you would buy stuff from made in Europe instead of China, and indeed this wire makes a good contact in every one of these, so I guess this old one is okay too, and this one here is actually an X one from Radio Shack when they still existed, and this one is not quite as good. It is better than those Chinese ones, mind you, but not as good as this blue one, and not as good as these yellow ones. But still, it does make a contact, so it is still better. So that's what I have. I've got a couple of old ones, and these Chinese ones, I think I'll retire them or something. That they also, like this little one here, the bottom came off it, so you can see all the little metal strips in there. Anyway, I'll have a look at that sometime. So that's another story. And this little hub over here, I've seen a lot of those suddenly appear, like on Amazon and so on, and different ones and different brands and what have you. The people that make this thing sent this to me. They wanted me to evaluate it and do a little write-up on it, and it has a HDMI port which is supposed to go up to 4K, and it's got 3 USB 3.0 ports and a PD port. So what I've already tested it, and I'm not going to test it in this session here, but I can tell you some things about it and some things to look out for when you buy these things, I guess. And that is that it comes with a little lead with a USB-C plug on it, but this little lead is very short and not a problem if you're using it with a tablet or a laptop. But in my case, I try to plug it into my desktop computer, and of course then it just hangs there. So I would have preferred it if this had a socket on there. Like I have one on my bench over here, an older one. It's a powered one, and it actually has a socket, so you can use any USB-C to USB-C cable. I would have much preferred that, but what it is marketed for is just to expand your ports on a little laptop or a tablet or something like that, I guess. So it may not be an issue if you use it for that. However, this port over here, that's a PD charge port. I have determined that it does work. It will go right up to 20 volts, which is required because it says it can handle up to 100 watts, which would be true if you at 20 volts. But it will only output charge voltage other than 5 volts if you plug this thing into a PD capable charge port in the first place. So it is just basically extending the PD port that you have on a laptop or a tablet or something. Then these three are just USB 3 ports, and I have determined that I plugged in an SSD drive, and just plugging it into my raw USB-C port on my computer, it was like 1069 megabytes per second or something like that. And if I plugged it into here through this cable here, it suddenly only did 469. So it was a little less than half the speed that I would normally get from the port. So that's something to be kept in mind. If you've got high-speed devices, then these things may not actually be good. You would probably want to dedicate a port on your computer if you got a high-speed port on your computer just for your external drives, and just put things like a mouse and a keyboard and lower speed devices into these ports. But that's how it works. There is also a HDMI output over here, and I have determined that it does work up to 4K, provided you have this plugged into a alternate capable USB-C port. I'm not sure if you're aware of that, but USB-C, USB 4, they have got so-called alternate modes, and you can put video on them, and high-speed transfers, and also PCI Express, I believe, and all sorts of things can now come through advanced USB-C ports. And so therefore, when I plug this into my desktop computer, which does have USB-C ports but it doesn't have these alternate modes, this did not work. But when I have a little tablet which does have that, it just worked fine. I was able to plug in a 4K screen and everything was hunky-dory. So that's one thing to keep in mind with that. So personally, this is okay just for extending, as I said, a laptop or a little tablet. But if you got more serious needs, which indeed I do, I would buy a powered hub, which then would have its own PD output, capable output on it. It should have a power supply, you know, that plugs into it and so on. And but you know, that's a much bigger and more expensive device. So it does work, and so that's what these things are all about. They are just like a little mini dock, if you like, for your laptop or tablet. And that is that. Oh yeah, when it comes to these microcontrollers too, as I said, I made up that little board that I can plug them into. This one over here. But I also made a probably year or more ago, a little board that I can plug them into, and then I've got the DuPont sockets over here that I can plug little cables into, and I put a little connector on there that I can apply power to it as well. So that's another thing that I use when I'm working with these wider microcontrollers. Alright, and another thing I came across is that when I made this thing and I put one of these boards in there for charging, it's got a charge input, it's got a voltage out, and it's got a voltage, no, this is, yeah, charge and a battery connection. So I bought some of these little lithium ion polymer cells, but it stopped working. I couldn't charge it anymore, and I found out that these guys have these little boards in there with MOSFETs and a little chip on there for cell protection. And I don't know if something's gone wrong with it, or if these little boards don't work with that kind of cell or not. But what I've had to do is I removed this little, underneath this Kapton tape over here, there is you can kind of just see it, but see, it's under there. I removed that little board and I soldered the wires directly to the cell, and now everything is working again just fine. So that's another thing that I didn't really realize. I just looked for some cells and I bought them, and that's what I got. I also have some small ones here, and I am not sure. There's also a little board there, but I'm not sure. I think they have little chips in them too. But as I said, I don't know what the deal was there. Did something here fail? I thought it worked before, but I'm not sure. But in any case, that little protection board we don't need, because this little board over here already has protection built into it. It'll never draw more than 4 amps on the battery, and the output is also protected as far as I know. So that's just another thing to be aware of. I thought I'd mention it. Now these little boards, as I said, I had a bunch of duds, or at least they did not work. I couldn't get the voltage down. The good ones, the voltage goes right down to less than 4 volts, and then you can crank it up right up to 27 volts. But the bad ones, 5.96 volts was the minimum, and I come to the conclusion that I removed it has a output circuit. So I took one of these little bad boards and I took off the resistor and the little potentiometer, and I just soldered on an external resistor here and a little trim pot, and lo and behold, the thing was working just fine. So obviously the value of those components, I do not know whether I sometimes get the impression that the Chinese make things, and the ones that don't work very well, they still sell them to people, and there are sellers out there that don't sell these things, and hope that people will buy them and, like me, not test them for like several years, and you can't send them back or something. I don't know. But in any case, what actually the output circuit here on these boards is, it's got a 100k resistor over here and a little trim pot and another resistor over here, which we'll have a look at it under the microscope in a minute. But the circuit is like this. From this diode, the output from this diode is fed into the 100k resistor, and there's 2 little pads across that resistor, and that is over here. I will look at that. Then there's a trim pot, and then there's a 2.2k resistor to ground, and of course the whole thing then is filtered by this capacitor over here, and that's why I always put an extra capacitor on the output, because these little chip capacitors, you know, they don't do that great a job at filtering out the 1.2 megahertz or whatever this thing is running at. So, but in order to calculate the voltage out, this is the feedback that goes to pin 3 of that little chip over here. There's an internal voltage reference, and it says it is nominally 0.6 volts, and then the formula is 1 plus R1, which is the 100k resistor, over R2, which is the combination of the 10k trim pot and the 2.2k resistor. Gives you the voltage out. So I don't know whether this little chip over here is slightly out of spec and its reference voltage is a little bit out, or these resistor values. I did measure the trim pot over there, and it seemed to be a bit nominal, like 9.6 kiloohms or something like that. So I don't know exactly. We will discover that. So what I've done is I have ordered some extra, these little trim pots over here. These are surface mount ones that are the same as those, These are 10k, and I have also broke out some other resistor, surface mount resistor values here. 3.9k that we can replace that 2.2k one with, 91k that we could replace the 100k one with, and I've got 100k ones also. So let's have a look what we can do. Okay, so this is the little board, and what we were talking about here is, put the soldering iron away for a sec, is here is normally the little 100k resistor, and there's these three little pads over here. This one is across the 100k resistor, which is over here. So there's two pads, one pad there and one pad here, and then there's another little pad that is just across the trim pot, and over here is normally where the trim pot sits. We're going to be putting a new one on, and here this is a 2.2k resistor, and so let's experiment here. We have our new little trim pot over here, and we are going to be, I'm going to actually put a slightly smaller 9.1k instead of a 10k, because well, let's work it out here. With this formula over here, let me temporarily change cameras over here so we can see what we're up against. Okay, so this is the formula over here, and R1's going to be, well, we're going to put in 91k, and R2 is going to be 10k, and we will assume that the VREF is going to be 0.6 volts. So let's have a look at the calculation. Now, have you guys noticed that all the smart guys on YouTube have these reverse Polish notation calculators? The reason is that it is a heck of a lot easier than those algebraic calculators. But when an algebraic calculator, just as you know, as an interest, you would put 0.6 volts times bracket 1 plus R1 R2 bracket and so on. Many more keystrokes required, and also it's easy to get lost, whereas a reverse Polish notation calculator, you don't need to put any brackets in or nothing. I'll show you how it works. So you go, I've got 100k, and you just hit enter, and okay, so it's 100,000. I didn't have to put all the zeros in. And R2 is going to be 10k. Well, that's the original value. Wait a minute, we were going to put in 91k, weren't we? Let's do it properly. 91k, 10k, and now I hit the divide button, so you can see both values here, 91, 10, and see 91,000, 10. We're going to do the divide over here. Doink. That's 9.1. Now the 1 plus, so we just hit enter 1. Now we hit plus, and we got 10.1, which is the result of that thing in brackets. As you saw, there was only 1, 2, 3, 4 keystrokes. Didn't have to put the brackets in or nothing. And now we just have to multiply by 0.6, 0.6, multiply, so we got 6 volts. And at 10k. But we know for a fact that with those resistor values, these little boards are actually coming back with less than 4 volts, the normal ones anyway. But the ones that I'm having a problem with, they do come back with something like 6 volts. So perhaps that is showing that these the VREF is different or something like that. Oh, wait a minute, we still made a mistake, didn't we? That's why it's not working out. Okay, R2 is not actually 10K, it is 12.2K. So let's do this again. Yeah, 5.07. And so that would be a better voltage. That's what we want. We want to get these things down to 5 volts because that's what I always use with the microcontrollers. Anyway, so that's how that will work. And I think the VREF must actually be less than 0.6 volts because I've got this little board over here, the good one. It'll go right down to 3.9 volts. So showing that that is actually the case. Anyways, so back to the job that we got to do. Okay, so I'm going to have a look. There's my multimeter leads are over here. Hold on. Yeah, remember that these two little pads over here are across that little trim pot. Yep. If I adjust the trim pot. So it is making a good contact, so that trim pot is in place. Now let's get our little resistor. Is this the right size resistor? I think it might be a little bit larger. It's a larger resistor than what we need, but that's the only size I've got, so we'll just have to make do. That real Amtech flux is really good. I think I'm gonna try to push it over a little bit. No, that didn't hold. Okay, let's add a bit more solder. think that is, but that flux, it sucks it underneath. It's 92.2. Seems to be making a contact. Anyway, I think it is okay. So everything being equal now, if I clean this up, there's my little, here it is. Okay, let's hook it up and see what it does. So let's hook up the multimeter to the output. That. So let's have a look. So instead of a battery, I'm going to hook this up to my bench power supply, which is what these leads are. And that's going to the battery terminals here. This is battery minus and battery plus, and I got it set to 3.8 volts, just like you would expect from a lithium ion battery that's had a little bit of discharge on it. And then I've got the output connected to my electronic load, which is set to draw 100 milliamps, just so that we can see what it does with a little bit of a load on it. Although these things can actually potentially draw a couple of amps, but anyway, so now I'm going to turn on the let me see if I can get this a little bit better. Turn on the power supply, and right now it says we've got 25 volts. Let's have a look. Oh, the multimeter needs to be on voltage, not on ohms. Okay, so now the minimum is 5.17 volts, which is quite acceptable. But let's turn on the electronic load here to draw some power. It's pretty stable, 5.16 volts. And putting a 91k resistor here instead of a 100k resistor is the way to go. Because if I put another 100k on there, I wouldn't be able to go down to a voltage as low as that. And to show you what the good ones do, where are we? Hooked up, and they go right down to 3.8 volts. Yeah, even 3.4 volt, by the looks of it. I'm going to set it for something like that, 5.14 volts. That is, it's always good to have a tiny bit extra than 5 volts on there. So this one is adjusted, and it's a good one. And now I'm going to test all these guys, but I don't have to do that while you guys are watching, because you know it's going to be the same. Okay, so I found several more bad ones. You can kind of tell which ones are the bad ones. They're obviously rejects. You can see over here these holes. So on some of them the holes are actually open on the sides. They haven't been cut right, and they are obviously rejects, and somebody in China no doubt bought those rejects and decided to resell them. And I got a bunch of those some years ago. I guess I never really tested them, but now that I am testing them, I find out there's a bunch of bad ones. And as I said, the ones on Amazon are fine, but the ones on the Chinese websites, I do not know where I got these from, if I got them from AliExpress or if I got them from Banggood or whatever, eBay, don't know, but these are bad ones. In any case, what we have here is I've been replacing these 100k resistors on some of the others with 91k, and that's worked for the majority of them, except I got one. It's still a little bit out of range. 5.5 volts is the lowest. And on this one actually I want to experiment. Now, as you have seen on this little circuit over here, that 2.2k resistor is actually part of the resistor chain that provides the feedback. So less resistance here or more resistance there will make the voltage go lower. So I want to see if I can replace a 2.2k resistor with something like 3k or something like that and see what happens. And that resistor is sitting over here. Now I do not have resistors that small. They are I don't know exactly what the size is, probably 0602. The smallest I got is 0805. And here, for instance, is one that is actually a reusable one. You can see the size. Hang on, let me pick it up a little bit differently. Actually, I'll change tweezers here. So these are bigger, and I don't know if I could get those to, I probably could to get the soldering underneath, but since this one has the 2.2k resistor between these two pads over here, I can actually place the resistor here, I think, or it needs to go to ground on one side, or I can just solder it between these two little pads here. So that's what we're going to try, but first I'm going to remove this 2.2k resistor to see what we are dealing with. I'm going to use our hot tweezers for that. I don't think I need to put flux on it, but I'll try it without first. Yeah, hot tweezers are magic, man. Okay. So that is gone, and so now I can have a look over here. This is one side. This should be going to, oh, let me put it on beep. Okay, so that pad connects to that, and this one here actually connects to ground. So we will solder it between over here and see what happens. Now just to double check what the value of this resistor is. Now it's got 3301, 330 and 1. Yeah, that should be 3.3K, right? It's hard to measure these things, and if you push too hard on them, they tend to jump away and you never find it going. Yep, it's 3.3K. So let's try that one. Okay, so where's my solder? Make sure I got some good leaded solder on there. Hang on. Oh. I think I want it over a little bit more. That should be good. Okay. Good enough for testing. So let me have a look now. I should now be reading 3.3K across those pads. Yep, we are. All right. Yeah, that's one way to deal with it, so I don't have to struggle. I'd have to buy some smaller surface mount components, and to be honest, when I'm doing projects that have surface mount components on there, the smallest ones that I use are these guys here, and they are about the same size as the one I put on there, but they are bigger than this one and bigger than the one that was on there. Maybe I should buy some smaller ones, I don't know. Anyway, let's test this thing out now. Okay, so I have plugged in the multimeter and I'm going to set it to voltage. Okay, and I'm going to hook up the, get rid of these things, the output, which is over here, minus and plus, and now we're going to hook up the bench power supply. I'm giving it 3.8 volts, which is kind of a nominal value that a lithium battery might have once it's half discharged. Alright, and we have 5.17 volts. Now let's adjust this little thing and see how high and how low it can go. Okay, that's going up. Well, it looks like 5.17 volts is actually the minimum, but that's good enough for a 5 volt output, so I'm going to leave it at that. So we have increased. It was 5.6 volts and now it's 5.1 something volts. with a 3.3k resistor there. I guess that resistor could be even a little bit higher, maybe even 4.7k or something, but this is what I had laying around, so that's what I used. Okay, so this one I consider salvaged. Here I have one that actually I have already replaced the resistor with with a 91k instead of 100k, but it's still too high. It's like, what was it now, 5.5 volts. It's a little bit nominal. I don't like that. I want it to be 5.1 or something like that at the most. Alright, so let me switch cameras here, stick it back on the microscope. Alright, let me get my 3.9k resistor out. What we're going to use. Okay, this is up to speed. 325 degrees on the tweezers. And they just lift off like they were never on there. Okay. Put that here. I'll keep those little guys. Solder. I could probably put these on with the hot tweezers, but it's a little bit tricky sometimes, and I prefer to just do it with the soldering iron, because I can just see now I can release it. But now I think I'll move it up a little bit because I want some room to okay, I sense that on this one I ought to put a little bit of flux. I don't like the way that went. There we go. Perfect. All right. All right, we got the right measurement there. Okay, so this is to be tested. Before we couldn't get below 5.5 or 5.2 volts, so it varied. You see these ones are definitely second, so the hole is open to the sides, but a little bit hard to connect the connectors to because they tend to jump off. Anyway, this is the output to the electronic load, and now we're going to hook up the battery input. Battery minus is over here. Battery plus is over there. What's the voltage? Okay, so it's hard to make a contact with those broken holes there. 5.1 volts. I've actually adjusted a little bit off camera there. So but right now, see, we can go right down to 4.6 volts, and this is where I like it. I like to have it so that I usually set these guys to like 5.1 volts like that, just a tad over 5 volts. So I think we have salvaged this one, so that's good. That's what you have to do sometimes with these guys. Does that get hot? Not too bad. Okay, so that's it. Salvaged about 4 of those things that I bought from I can't remember where I got them, AliExpress or Banggood or eBay or whatever, a couple of years ago. They were obviously seconds and somebody sold them as good ones, but we've been able to fix them. I think what is happening is that this chip over here is a little bit out of spec. In the datasheet, in fact, it already says usually the reference voltage is 0.6 volts. So this is indicating that they can vary a little bit. And I think that maybe they chose the component values in that feedback loop a little bit poorly, so it doesn't have enough adjustment. I don't know. But now we can use them, so we salvage them. Okay, so that was a bit of a mixed bag today, and that's all I've got for now. Don't forget to subscribe and like and all that kind of stuff. So in the future, I'm going to do a few more projects, and I had a few people comment that one asked how you write to one of these RFID cards or devices, and this is actually a little kit that I received recently, and I believe that this little board here is able to write as well as read RFID, so I'll be investigating that and doing a little video on that as somebody requested. Also, somebody suggested that asked how one might go about receiving hidden information like from a keyboard through Bluetooth instead of outputting it and then actually outputting it via USB. So in the reverse of what I've done. I hadn't thought about that. I'll have a look at that, see how possible that is. I also have some other devices that eventually I will look at. This here is a little chow board with a camera. It's ESP32S3 with a little camera module included. This is a TDAC from LilyGo, or T keyboard I call it, do they? No, here it says TDAC and here it says T keyboard. In any case, I'm planning to do something with that. And of course there's this ubiquitous little yellow board that has an ESP32 on there and a bunch of connectors and a little screen. I'm looking to do something with that. And finally, this device here is a USB host board, and this was originally developed by somebody some years ago for Arduino boards, and I think it originally was meant to plug into something as like a little hat or something, but this is a Chinese clone, and the actual thing is not the same as the original was, and it's a little bit tricky. I made a picture of it over here and found out that this particular one, it has two inputs, VL and VBus, and you really have to cut that trace over here and put 5 volts on that pin and 3.3 volts on that pin. And this particular chip here is a relatively well-known Maxim board, chip I should say, and it uses SPI bus, but it also sports actually GPIO pins for input and output, 8 of each, which is an optional thing, which is not used by the USB part of the chip so much. But I think the explanation was that if you're going to, on some small microcontrollers, if you use the MISO SS clock and the interrupt pin, which is typical that you need, then there might not be very many GPIO pins left. So this chip then um, gives you the ability to add an extra 8 inputs and outputs to it, for whatever that's worth. Now, I've had a look at this. There is a host library, an Arduino one, which has been around for a while, I think, but I could not get it to work, and I looked at the code and I thought it was horrendous, very complex and convoluted, no comments to speak of, and I cannot use it, and I don't want to use it. So this is going to be a long-term project. If I complete it, I'll be making my own library, and then I'll have videos on how to create these libraries for Arduino and so on, so everyone can learn along with me. USB is notoriously hard. This chip has 26 registers in it, and it can either act as a device or a host, and you've got to program these registers and so on to make it work properly. So you've got to have knowledge of the USB protocol and everything like that. So it's not going to be a simple job, but it'll be fun to do, I'm sure. And if and when I get this done, I'll do a video on it. It'll be, and if I've got a library, of course, then people can use it, and it'll be easier to use, but there'll be an advanced video on how that is done as well. Anyway, that's all I've got, as I said. Don't forget to subscribe and like and all that sort of thing, and I'll see you guys next time.